The last one is one of my favorites. And this one I like to call embracing the suck. Okay. Now, this is especially dedicated to my pre-calculus students. We get them sometimes in algebra 2, but I feel like a lot of times in algebra 2, we're not challenged, enough. And so once we get into pre-calculus, we get a problem that has a little bit of deviation from what our teacher had taught us. And then we just want to like give up. Okay. And so this is one of those common mistakes that I'd see, especially earlier in the year in pre-calculus. And then once we go through this a little bit of coachability, students get more comfortable. Now, remember I talked to you about, simplifying things. And a lot of times students will look at this and they'll say, all right, I got to go ahead and, factor these two to kind of see if there's any holes or anything like that. But then they look at this numerator and you say, what two numbers multiply, give me 3, add, give me 3. Ah, crap, that's not factorable. Oh crap, if it's not factorable, then I just don't know what to do with it. And they'll just like stop or give up or make up an answer. Or they'll say no x-intercept, right? So if I say, what's the x-intercept? They say, I don't know, that's non-factorable, right? So x squared plus 3x plus 3 equals 0. That's non-factorable, must be complex solutions, so no x-intercept. Well, ladies and gentlemen, remember for a quadratic, we could have, 2 real, we could have no solution, right? That example. Or we could also have 2 irrational, right? We could have real, but they could just be irrational and not rational numbers. So what do we got to do? We got to do the quadratic formula. Now, a lot of times students don't want to do the quadratic formula because 1, maybe they forgot it, or 2, they just don't want to do that extra work, right? They're doing their homework or they're taking the test. They're like, man, did I do something wrong? And no, just because you're having to do the quadratic formula doesn't necessarily mean that you did something wrong. But if your teacher hasn't gone through directly a problem like this, you might feel that way. And so I totally understand that. And I would try to always do as many problems as I possibly could for my students. But ladies and gentlemen, it's just not possible for me to be able to go over every single type of problem or every single time that you could possibly use the quadratic formula. Okay. So just make sure that you set your numerator equal to 0. If it's not solved by factoring, that doesn't mean there's no x-intercept. Use the quadratic formula. Now, obviously, if there's irrational or imaginary solutions, there's no x-intercept. But in this case, we're going to have 2 real rational solutions. So I just need to figure out what those are. So 3 squared is going to be 9. Oh, that's supposed to be a negative 3. I wanted that to be a negative 3. Well, oh yeah, I wanted that to be a negative 3. I messed that up. I don't want them to be irrational. I want them to be rational or real. I want them to be irrational real. So that's supposed to be negative 3. Apologies for that. I don't want them to be complex. So let's make that a negative 3. So that's going to be a negative 3. So therefore, that's going to be a positive 12 divided by 2. So in this case, 0 is equal to a negative 3 plus or minus the square root of 21 divided by 2. Those are my x-intercepts, right? So x equals a negative 3 plus a square root of 21 divided by 2. And x equals a negative 3 minus a square root of 21 divided by 2. It doesn't look really pretty, right? But you can write those as coordinate points. Those are x-intercepts. Those are just as equal to our integer solutions, okay? So don't disparage our irrational friends. And then again, on the y-intercept, ladies and gentlemen, don't let something be non-factorable mess you up, right? The y-intercept is when x is equal to 0 or constant over constant. So therefore, that's simply just going to be a 0, comma, a negative 3/2. So that's going to be a negative 3 divided by a 2.